Alright guys, we're going to be using the fundamental theorem to find the values of f of x given the graph of f prime of x. It is a calculus AB exam free response. So in this question, given that f is differentiable on the closed interval -6 to 5, we will be in fact calculating the values of f of -6 and f of 5 from the graph of f prime of x as depicted below. You're going to have to excuse my spelling if I spelled anything wrong on this, by the way. So in the first one, we're going to consider f of -6 in this problem. Now we are given the initial kind of condition down there where f of -2 is equal 7. And here coming up, we're actually going to break this, that first integral that I'm about to set up for this right here from -6. And then actually over here, this area of the triangle up into x is equal to -2 there. And then we're going to consider the semicircle and these two triangles. Keep in mind that your semicircle is definitely going to be negative value because it is beneath the the x-axis there, y equals 0. So we need to consider that whenever we set up our net integral here, that we're going to be splitting up for the graph of f of prime of x, which is going to be our function, of course, that we're integrating. Now on this, again, we were given that f of -2 is equal to 7. This is where I'm actually going to break up the integral. So let me label my axes. Just give me a second here. Alright, we're going to be doing the area of this one. I'm going to set that integral up in a minute. Okay, so here it is. This is going to be from -6 to 2. -2, sorry. F prime of x. This is the graph of f prime at dx here. And let's go ahead and break this up using our fundamental theorem here. So I'm actually going to take this from -2 there, subtract that from f prime of -6. And that f of -2 should come out to you there that's given. Yeah, so f of -6 here is what we're looking for. And this is the application there of the fundamental theorem, so that's how I'm going to break up most of these. We're actually going to consider the area of that triangle, so let's get this calculation over here in terms of that integral. Kind of take that as we can actually use geometry to get that as an exact value, in fact. So let's go ahead and utilize this. This has a change of base of 1, 2, 3, 4, and a height of 2. So put in your triangle formula for area, 1/2 base times height. I'm going to go ahead and plug these in. So this is going to give us 4 for this entire representation of our integral. And that's good because now we have a situation where this is 4, right? I can set that equal using the fundamental theorem to these two, I guess you could say, heights respectively, which is why the fundamental theorem is so useful. You can compare areas to values of the parent function. Of course, if you're doing any other, integrating anything out there, you would be getting a function if you didn't have limits of integration. The connection is we're kind of dealing with the connection here, which is the fundamental theorem. So now I can express these, this change here equal to the area, and then I can solve for f of -6. And guys, that's just pretty straightforward. That's all there is to this. And you can now isolate f of -6, and we'll have the answer to this. So give me a minute to kind of finish this one off. And we'll move on to the other question, f of 5. So here, I'm going to add a 6 and then subtract 4 here. Needs more space. Alright. Okay, so f of -6. So I meant to make that a -4, so make sure you correct that. I'm about to correct it here. Give me a second. So they did give us that f of minus 2 is 7. I'm going to go ahead and plug that in. Alright, let me fix that. Minus 4. There we go. And so this is going to be the value of f minus 6. So it's going to be equal to 3. Now let's go on to the next part of the problem where we need to do, f of 5. And we're going to be splitting this up, like there's going to be much more involved for f of 5. So kind of have some space ready. And we're going to be considering all of these geometrical intervals here, where you've got -6 to -2, -2 to 2, 2 to 3, and 3 to 5. I'm going to represent those each as a separate integration right here. So here we go. So again, for the semicircle, -2 to 2 as well. And then you really want to split this up into two triangles, which we can totally do, so we're going to do that. That's from -6 to to -2 there. Okay, so I just want to make that obvious. And this is from -2 to 2. So I just wanted to let y'all know that I'm having to redo my audio because I forgot to include my mic in the video. So if it seems off, that's what I've been doing here. I apologize for any inconvenience, but that is going to be like I said, -2 and -2 to 2 there. We're going to split this up, right? So maybe I'm using the wrong terminology, but I think it's a net change theorem, fundamental theorem. Doesn't matter. This is how I would do it. I just do math and applied math. So one way or another, you could say that it's that. But anyway, I am using, in my mind, the fundamental theorem. We need to break that up because we need to isolate f of 5. So it's very important to do it step by step. Now remember that the integral from -6 to -2 was 4, and the semicircle, we're going to need to switch that sign to a negative sign because that is from -2 to 2. So just make sure you're breaking up the pieces that you need to. And what can be confusing is, sometimes it seems like you're doing things more than once, but just follow the formulas. Just follow the net change, or the fundamental theorem here. I'm taking a net integration. I'm breaking up every single interval here. Now this is going to be -1/2 pi r squared for our circle on -2 to 2. And now this is going to be the triangle from 2 to 3. We're going to use 1/2 base times height, of course. And we're going to split that and actually make another triangle, right? Let's not complicate that and use vectors, right? So we're just plugging in values now at this point, so give me a moment, save a little bit of time. You can jot this down. And so I did bring my f of -6 to the other side so I can get, now don't freak out, I've got another cursor, so I could get this f of 5 isolated by itself. And we have in fact f of -6 already as well. That was 3, remember. Now 1/2 pi r squared, your radius is 2. That's 1/2 pi 2 squared. 1/2 base, that's 1 times height of 2. And so again, f of -6 is equal to 3 here. And again, so 1/2 1 times 2 plus 1/2 2 times 2 for the second triangle. And this is it, guys. You just sum up all your integrations, and that's the answer for f of 5. Hope this helps. AB, this is AB, one of the AB exam free response questions. So, so apologize for any audio lapses. Everyone have a good night. Merry Christmas, I guess. It's about almost that time.
Yeah! Ninja, vanish!